Hey mathematics learners, welcome to Distance Learning with Lee, where I make learning mathematics super easy. On today's video tutorial, we are going to be going through circles in analytical geometry. And this video is a part 2 video, so make sure that you watch the part 1 video that I recorded for you guys on analytical geometry. I will put the link to the video on the description box. But before I get started with my video tutorial, I would also like to just say thank you to everyone that is subscribed to my channel. I really appreciate the support, and I also appreciate the words of encouragement that I receive from learners that find my videos helpful. Right, my YouTube channel is all about simplifying mathematics and making it fun and straightforward. So if you are a high school learner in grade 10, grade 11 or grade 12 and you are just finding it hard to study mathematics, then this channel is for you. Right, I will be showing you how you should easily approach all your mathematics problems. So please make sure that you are subscribed to the channel if you haven't, and also share the channel with your friends. Alright, and as usual, without any further ado, let's get started with today's tutorial. Get your note pads or your exam pads, your pens and your highlighters, and let's get started with today's video tutorial. So like I mentioned, today's video tutorial is going to be about circles in analytical geometry, right? And the two scenarios you might be tested on, which are the first one, when you're given a circle that has the center at the origin, and the second scenario is when you are given a circle and the center is not at the origin. Right, I'm going to be discussing with you guys the approach you should use in each scenario, okay, and the general formula that you guys should be using for when the center is at the origin, right, and the general formula that you should use when your center is not at the origin. So let's talk about the learning outcomes for this video tutorial, or what you should be able to do after watching this video tutorial, right? So from watching this video tutorial, you should be able to determine the equation of a circle, right, from these two scenarios, right? You should be able to determine the equation of a circle when the center is at the origin, and you should be able to determine the equation of a circle when the center is not at the origin, right? Let's check out the second learning outcome for my video tutorial. You should be able to determine the coordinates of the center point as well as the radius given the equation of the circle. So that's the second thing you'll be able to do from watching my video. And lastly, you should be able to determine the coordinates of the center and the radius by completing the square. Right? So after watching my video, you'll be able to determine the equation of a circle given the two scenarios that I mentioned. You should be able to determine the coordinates of the center point as well as the radius given the equation of a circle, and you should be able to determine the coordinates of the center and the radius by completing the square. Alright, so keep it locked to the video.
Before we get started with our tutorial, let's have a look at important definitions that you guys should know when working with circles in analytical geometry. Right, the first one is that a circle is made up of points that are at an equidistant from the center. So that is our definition of a circle, right? And our definition of a circumference is that it is the distance around the whole circle. So that is our circumference, that distance there around our whole circle, right? And what is our radius? The radius is the distance from the center to the circumference, right? So it will be the distance. So if this is my center there, if that is my center, the radius is the distance from that center going to the circumference. So that is my radius. And the circumference would be the distance around the whole circle, right? So that is my circumference and that is my radius. So let's have a look at what is meant by a circle with the center at the origin, right? So what this means is that if you have a Cartesian plane and our circle is on our Cartesian plane, then the center of this circle will be at point 0, 0 on our Cartesian plane, right? So at this point here, which is 0 and 0, this would be our center of our circle. That point there would be the center of our circle, all right? Now, how would we derive, right? How would we derive the equation of a circle with the center at the origin, right? So I just want to show you guys how the equation of r squared, the equation of r squared, which is equal to x squared plus y squared came about, right? So this is just for the learner that just wants to understand how this equation was derived, right? So this is what I'm explaining to you guys, right? So this is how this equation is derived. If you have a point O, which is at point 0, 0 on our Cartesian plane, and you have another point on our circle, right, on the circumference of our circle, and we are going to call that point point P, okay, and then we are going to call that our point P. To get the length of our line OP, we use the distance formula, right, to get the length of our line OP. And what does the distance formula say, right? If this is our point O and our point P is given as the coordinates of our point P is X and our Y, using our distance formula to calculate the length of OP, we say that OP is equal to the square root of, and then I said that I love labeling my points. If I'm going to call this my point 1 and I'm going to call that my point 2, right? X2 minus x1 all squared plus y2 minus y1 all squared, right? So that is the formula that we use to get the length of OP, right? So now we're just simply going to substitute. I labeled the point O as the first point, and I labeled my point P as my second point. We are just going to substitute those points into our equation. So what is our x2? Our x2 is our x minus, what is our x1? It's the 0, right? All squared plus, what is my y2? It's just the y minus, what is my y1? It's 0 all squared. And if we have to simplify this equation further, x minus 0 is the same as saying x. So you're going to have x squared plus y minus 0 is the same as saying y. So it's y squared all under the square root, and that is equal to our OP, right? And then what do we know about OP? Okay, OP is also defined, it's our radius, right? OP, line OP is the radius of our circle, right? If I just put that, then just show that this is my radius, right? You can just simply say that OP is the radius, which is equal to x squared plus y squared, right? And if you want to just get rid of the square root sign on your right hand side, you just square both sides to give you that r squared is equal to x squared plus y squared, right? So this is how the formula for a circle that is centered at the origin was derived. So now that we have the technicality sorted, let's get to how this can be applied in a practical example involving circles centered at the origin. So let's look at example 1, right? Example 1 says that we need to find the equation of a circle centered at the origin with point P, and our point P is 5 and 2 on its circumference, right? So how does this look roughly, right? So we basically have that there, and we know that we have a circle, okay? And this circle has its center at the origin, right? And then we also know that we have a point P that is on our circumference. So that is our point P. We know that that is our point 0, 0, right? And then we know that that point P is 5 and 2. We need to find the equation of this circle, right? So the first thing we know is that we need to use the general equation of a circle that is centered at the origin, right? And that general equation is given as r squared is equal to x squared plus y squared, right? We know that our x point is 5 plus we know that our y point is 2, and then we can just simplify this. 5 times 5 is 25, plus 2 times 2 is 4, and that gives us 29, right? So our r squared is equal to 29. Therefore, the equation of this circle that has the center at the origin with the point P on its circumference is x squared plus y squared is equal to 29, which is our r squared. Now, let's get to circles that are not centered at the origin, right? So we're going to first start off by just explaining how this circle will look, right? So in terms of a circle that's not centered at the origin, it has the center at point A and B on our Cartesian plane, right? And then we also know that we have a point P somewhere on our circumference. We have point P somewhere on our circumference, the circumference of our circle, right? So that is our point P, right? And I'm just quickly gonna explain to you guys or show you how the equation or the general equation for a circle that is not centered at the origin was derived, right? So we know that obviously this is our center point, and our center point is at point A and B. And we know that obviously we've got a point P that is on our circumference of our circle, and this point is x and y, right? How would we calculate the length of the line CP? Right? Using the distance formula, we know that the length of CP will be calculated using the formula is equal to x2 minus x1 all squared plus y2 minus y1 all squared, right? And like I always mention, I like labeling my points. So our point C will be our point 1 and our point P will be our point 2, right? We are just going to substitute that into our equation, right? What is our x2? Our x2 is our x minus what is our x1? Our x1 is our a all squared plus what is our y2? Our y2 is just the point y minus what is our y1? Our y1 is our point b. Alright, so you're going to have b there all squared, and that is our CP. Alright, so what do we know about CP? CP is also what? The radius of our circle, okay? And why is it the radius of our circle? We defined the radius as is the distance from the center to the circumference of our circle, right? So therefore our CP is our radius of our circle, right? Okay, which is our R, which is equal to, I'm just going to repeat that there, x minus a all squared plus y minus b all squared, right? To get rid of the square root sign, you can just square both sides, and then you're gonna have your x minus a all squared plus your y minus b all squared, right? So this is basically how the equation for a circle that's not centered at the origin was derived. So we know that the general equation you should use for circles that are not centered at the origin is r squared, which is equal to x minus a all squared plus y minus b all squared. Right. So now let's look at a related example. So let's look at our example 2. Right. The equation of a circle is x plus 1 all squared plus y minus 3 all squared is equal to 16. We need to determine the coordinates of the center and the length of the radius. Right. So for this question, we are required to determine the coordinates of the center as well as the radius, right? The length of the radius of our circle. I'm going to give you guys just 1 minute to quickly write down this question and attempt it on your own. So pause the video, attempt the question on your own, and once you're done, just play the video and see if you managed to get it correct. All right, we are required to get the coordinates of our center, and we're also required to get the length of our radius. We're going to start off by getting the coordinates of our center. What can we already see with this equation, right? We can see that this equation is in the general form of x minus a all squared plus your y minus your b all squared, which is equal to our r squared, right? This equation is in that general form there, right? So what do we know of values that are in our brackets? We know that these two values tell us about the center of our circle, right? So our x plus 1 and the y minus 3 tell us about the center of our circle. And this value here tells us about the radius of our circle, right? Therefore, we can conclude that center of a circle can be obtained by just solving for, we're going to just solve for x here and solve for y here to get the coordinates of our center point, right? And we are just simply going to say our r squared is equal to 16 and solve for r to get our radius. Okay, so let's just get cracking. Let's do that. Let's solve for x. So x plus 1 is equal to 0, meaning that our x is equal to negative 1 and our y minus 3 is equal to 0, so our y is equal to 3. Therefore, the coordinates of our center is the point negative 1 for x and 3 for our y, right? We said that our r squared is equal to 16. So you're going to say r squared is equal to 16, making our r, so r is going to be equal to the square root of 16, which is equal to 4. Right. Therefore, we have calculated what we needed to calculate. We've determined the coordinates of our center, and we've also calculated the length of our radius, and we found that the coordinates of our center is negative 1 and 3, and we found that our radius is equal to 4. Alright, so let's look at the next example, right? So the next example says that we need to determine the coordinates of the center and the length of the radius if the circle has the equation x squared minus 2x plus y squared plus 10y is equal to negative 14. Right, so we need to determine the coordinates of the center and the length of the radius given this equation. Okay, so already we are becoming a bit confused because now we can see that this equation is not in its general form of x minus a all squared plus y minus b all squared, which is equal to r squared, right? So we need to get this equation into that general form, okay? So just quickly write down this question, attempt it on your own, try it on your own, and just like figure out how we can get this equation into the general form of x minus a all squared plus y minus b all squared, which is equal to r squared, right? Figure it out, try it out on your own, then play the video. So like I mentioned, this equation is not in its general form, right? So we need to get it in its general form. How do we do that, guys? How do we get this equation to be in the general form of x minus a all squared plus y minus b all squared, which is equal to r squared? how can you get this equation to be in that general form? Okay, so how can you get this equation to be in that form? So this is a light bulb. This is actually a light bulb moment, guys, right? So if an equation is in this form, right? If your equation is in this form and you need to get it into the form of x minus a all squared plus y minus b all squared is which is equal to r squared, you guys need to remember that you need to complete the square to get this equation to be in that form. All right, so let's just do that. Let's complete the square and see what happens. All right, so how do we complete the square, guys? Okay, firstly, we're going to just group our terms, right? So I'm going to group that. So I'm going to have x squared minus 2x. How do we complete the square? So this negative 2, so you're going to take your negative 2 and divide by 2 and square it, right? So you take that negative 2, you divide it by 2 and you square it. Plus, right? We're going to take this positive 10, we're going to divide by 2 and we're going to square it. Okay, so that's how we're going to this for this section. Okay, plus it's going to be your y squared plus, you're going to write the 10y, right? And then plus, we're going to take 10, positive 10, we're going to divide it by 2, and we're going to square it, which is going to be equal to negative 14. Right, tell me what negative 2 divided by 2 all squared is equal to. This value is equal to 1. Okay, so this value is going to be equal to 1, and that value there, so positive 10 divided by 2 all squared is going to be equal to 25. Let's actually write these values down so that we do not get confused. Right, squared, so your final answer is going to be x squared minus 2x plus that 1 plus y squared plus 10y plus 25. Okay, and I'm going to bring your attention to these values that we've just obtained now, right? We obtained a plus 1 and we obtained a plus 25, right? So what we're going to do with these values, what you do on your left hand side, you're going to do on your right hand side. You need to add these values to the right hand side of our equation. Right, we know that we're going to that is going to be equal to negative 14, and you're going to plus the 1 and you're going to plus the 25. Okay, and that's going to plus that 1 there plus the 25. Okay, I'm just going to quickly go through what we did here to complete the square. Okay, what obviously group our terms, right? So the x's together and the y's together, right? And then you take your negative 2, so the value that has just the coefficient of x and the coefficient of y, you take that term, so it's going to be negative 2, you divide by 2 and you square it, right? And you take the coefficient of y, you divide by 2, so that positive 10, you divide by 2 and you square it, right? And since you added it to the left hand side, you added the negative 2 divided by 2 all squared, and you added the 10 divided by 2 all squared to the left hand side, you need to add to the right hand side, and that's what we have here. Okay, let's just simplify our equation further. So I'm just going to rewrite this. So you've got x squared minus 2x plus 1 plus y squared plus 10y plus 25, which is equal to negative 14 plus 1 plus 25 gives us a positive 12. And then, guys, we are just going to factorize these two parts. Okay, we have to factorize this part and we need to factorize that part. Okay, so let's do that. Okay, so we're going to factorize using basically the process of, or the method of inspection for both of them. 12, right? So it's x there and x there. We want to get a positive, so it's going to be a negative and a negative. And then the factors of 1, that if you minus them together will give us a negative 2, it's minus 1 and minus 1, right? Let's factorize the second part, right? You've got a y and y, and you want to get a positive there, and you've got all positives, so it's going to be and a positive, right? And then the factors of 25 that if you plus them together will give us 10, it's 5 and 5, right? What do we see here, guys? We see we've got x minus 1 all squared plus you've got y plus 5 all squared, and that is equal to 12, right? And ta-da, we have this equation finally in its general form. Therefore, we can get the center of our circle as well as the radius. Okay, so I'm just going to rewrite what I had there. So we had our x minus 1 all squared plus our y plus 5 all squared, which is equal to 12. And we can see that this is in its general form. Then we can just solve or get the coordinates of our center. And we said that to get the coordinates of our center, we just solve for our x and we solve for our y. So x minus 1 is equal to 0. Therefore, our x coordinates of our center will be 1. And our y coordinates, y plus 5 is equal to 0. Therefore, our y is going to be equal to negative 5, right? Therefore, the coordinates of our center will be 1 and negative 5, right? And then what would our radius be? Because we can already see that this is in the minus a all squared plus y minus b all squared, which is equal to r squared. Our r squared is going to be equal to 12, right? So our r is equal to 12, and therefore our r is going to be equal to the square root of 12, which is equal to, we'll just leave it in its third form, right? Okay, so we'll leave the r, the radius, in the third form. Right, so we've already calculated our center for our circle, and we've also calculated the radius. Now let's look at an example where you're actually given the center of the circle and it's not at the origin, and you're also given a point on the circumference of the circle, right? So let's check out this example. So this example says determine the equation of the circle with center C, which is negative 1 and negative 2, and passing through the point 1 and negative 6. So what do we know, right? What do we already know? We can already tell that this as a circle that is not centered at origin, because hey, right, we can see that this is not our point 0, 0 on the Cartesian plane. So this is a circle that is not centered at the origin, right? And it is passing through a point B, right? And we need to determine the equation of the circle, right? We already know that the equation of the circle is going to be in its general form of x minus, which is r squared, r squared, which is equal to x minus a all squared plus y minus b all squared, right? So we want to get an equation that is in this general form because this circle is not centered at the origin, right? So we are given the center points, right? We're given the center points, which is x, which is equal to negative 1, and the y, which is equal to negative 2. So we are literally going to write that down. We're given the center points, right? We're given the center point, okay? So our center points are, they told us that our x is equal to negative 1, right? So our x is equal to negative 1. And we know that our y is equal to negative 2. So we're literally going to put that y is equal to negative 2. Y is equal to negative 2. Alright, so what do? We just need the x, so transpose the x to the left hand side. So we're going to have x plus 1, which is equal to 0, and y plus 2, which is equal to 0. So we're going to literally just put that into our equation, right? So we're going to put that into our equation of r squared, which is equal to, we're going to write x plus 1 all squared plus our y minus b, which is our y plus 2. I'm going to put that there, which is our y plus 2 all squared, right? And we are short here. So how can we calculate our radius? We are given another point on our circle. And what is that point that is given to us? Right? It's the point B. We are given the point B. So what do we do with that point? Okay, I'm just going to rewrite the equation here. Okay, so I said that r squared, which is equal to x plus 1 all squared plus your y plus 2 all squared, right? And then I mentioned that we are given a point B, so another point on our circle, because we are trying to calculate the radius of our circle. So let's work with the other point that is given to us, which is our point B, right? And our point is your 1 and negative 6. So we are simply going to substitute that into, right, to get our r squared, right? Our r squared is going to be equal to, where you see your x, you're going to 1 plus 1 all squared plus, where you see your y, you're going to put it to 6, negative 6 plus 2 all squared. All right, so what is our squared? So 1 plus 1 is 2, all squared is 4, plus minus 6 plus 2 is minus 4, and that all squared, minus 4 all squared is positive 16, right? So that's your positive 16, and that's your r squared, right? Therefore, our r squared is equal to 20. Okay, so the equation of this circle, okay, therefore, the equation of our circle is going to be our x plus 1 all squared plus your y plus 2 all squared, which is equal to 20.
So that is it for our video on circles in analytical geometry. I hope that I made the concepts easier to understand, and I just summarized everything for you guys in a very simple and straightforward manner. Please make sure that you are subscribed to the channel if you guys are not. And the next video that is going to be coming up is going to be about the equation of a tangent to a circle, which is another section in analytical geometry. And that is it, guys, and I'll see you guys on my next upload. Goodbye.